let's go through the example together. On the side here, you can see the transformations that are already noted. So we have a reflection. We don't have a reflection, so that's not applicable. We don't have a stretch or a compression. We don't have an A and we don't have a K, but we do have a D value, 3 units to the right, and a C value, 2 units down. The domain and range are based on the original absolute value parent function. So normally the domain is all real numbers, and that's not going to change. The range, however, because we're shifting it 2 units down, instead of being greater than or equal to 0, will now be greater than or equal to -2. And then what we do is we use the transformation that you can see at the top of the page there, just as a reminder, that all the original x, y's from our function, so I can rename here an x and a y, from the original absolute value function, will be transformed into new points. And the new points change because of k, d, a, or c. So we don't have a k to worry about, but we will add d and we will add c. So let's apply that to the points we have. If we start with an x value that's -2, -2 is going to be increased by d, so increased by 3, and you get to +1. And our y value, which was a 2, is going to be decreased by 2. So if I add -2, or if I shift it down by 2, 2 becomes 0. Do that again. So if x is -1 originally and we add 3, we're going to get to 2. And if we take our y value of 1 and decrease it by 2, we get to -1. Repeat, 0 plus 3 is 3. 0 minus 2 is -2. 1 plus 3 is 4. 1 minus 2 is -1. And 2 plus 3 is 5. 2 minus 2 is 0. So these 5 points now will make up our new absolute value function. So if you just plot them, 1 and 0, 2 and -1, 3 and -2, 4 and -1. You can see the shape is V-shaped again. That's what we wanted. Let's get the last point in there. And then you can connect it with lines, put arrows on the end because the domain is all real numbers. Goes on forever. Okay, and also in terms of the shape, you can see that there wasn't a reflection, so we've verified that. There wasn't a stretch or compression. There's a slope of 1 on either side, so the shape hasn't changed. And we did move it 3 units down from the origin, and we did move it, 3 units to the right and 2 units down. So the domain and range kind of check out. If you started with a x squared function instead, we're imagining a parabola. You look here for an a value or a k value that would cause a reflection, and there isn't one. You look for a k value or an a value to cause a stretch or compression, and there isn't one. But we do have a shift, so our shift is 2 units right. Oops, sorry. Fix that. 2 units right. Okay. Pen going 2 units right and 4 units up. Okay, the domain for any parabola is still x is a real number. But remember, the range, depending on the situation, can change or is restricted in some way. So it used to be y is greater than or equal to 0. But if I move this shape 4 units up, it's going to be y is greater than or equal to 4. And the parabola still opens up, so that's why I chose the greater than symbol. On the table, originally, we have x and x squared. So you could fill those in with common values like -2, -1, 0, 1, and 2. But eventually we're going to find the image of this point. So we want to know f at x. What will our new x and our new y be? Okay, so in the original parabola, when I square x, -2 times -2 is 4. 1, 0, 1, 4. So that's how you get that U shape. If we look at our mapping transformation now, x, y will become a new point, and it'll be x over k plus d and ay plus c. So let's highlight the ones that are important. Because there's no reflection, no stretch or compression, we're not going to worry about k, but we do have a d value, 2 to the right, so plus 2, and 4 units up, so plus 4. Okay, so the original x value is going to be x divided by 1 because we don't have a k value, so x plus 2. That means that the new x is located at 0, and the 4 is increased by 4, so it's going to be at 8. Negative 1 plus 2 is 1, and 1 plus 4 is 5. 0 plus 2 is 2. 0 plus 4 is 4. 1 plus 2 is 3, and 1 plus 4 is 5. 2 plus 2 is 4, and 4 plus 4 is 8. So we do have this symmetrical shape again. You'll see it as I graph it. 0 goes with 8, 1, comma 5, 2, comma 4, 3 then goes with 5, so you can see the U shape, and 4 with 8. Once again, if we verify on the side, we don't have a reflection, we don't have a stretch or compression. The vertex moved 2 units to the right and 4 units up, and my range is correct. It's y is greater than or equal to 4.